Hey guys, welcome back. It's me, Sahil Mahajan, and in today's video, we're going to be taking a look into the complete basics of Amazon databases. So this video is a pretty long video. It consists of all of the databases that Amazon does have. We go through an overview of these databases, and we also dive into a demo for these databases. As according to my previous videos, I have created chapters for this video, so at any point in time you guys want to come back or you want to skip to a specific database, you can go ahead and use the chapters. So I hope you guys do like this video, and let's dive right into our first database, that is Amazon RDS. And in today's video, we're going to take a look into RDS. So RDS basically stands for Relational Database System. So let's dive right into the video. So again, RDS stands for Relational Databases. It basically consists of rows and columns. You can think of an RDS as an Excel sheet wherein you have various different rows and columns wherein data is stored. Um, RDS, there are various different engines out there, database engines out there, where you can create a relational database. A few prominent and famous ones are the SQL Server by Microsoft. You have PostgreSQL, Oracle, MySQL, and Amazon Aurora. I'm pretty sure most of you would have heard about these four databases, but many of you would have not heard about Amazon Aurora. And Amazon Aurora is basically an AWS created database. It is not an open source database. It's completely created and managed by AWS. So moving on, let's talk about a couple of advantages on, why should you host your relational database in the cloud, and to be more specific, why should you host it in AWS? The first thing is that it is up and running in minutes compared to setting up a traditional database on your own on-prem server or an EC2 instance. If you use the managed RDS service that is provided by AWS, you can easily create your database within a couple of minutes and be ready to use it for any use case that you have. Another good functionality is that it has inbuilt failover capabilities. It has automated backups. For example, you can set the duration that after every 24 hours you want to take one backup, or whatever the time duration you guys wish to be according to your use case. You can take those backups. It provides multi AZ support, that is multi availability zone support. That is, you can have primary databases and you can also have your secondary database. Another good functionality is auto scaling. Now, you may have initially set up 100 GB SSD for your relational database. But what if you are at 80 GB, you're using 80 GB, that's 80% capacity, then AWS will automatically auto scale your storage capacity for your RDS instance to manage that. And another really cool functionality that I really like is called read replicas. We will be diving into more details about what are read replicas, but this is a really good functionality. And finally, I just want to take a look into OLTP versus OLAP. This is something that is pretty important that you guys should know and have a good understanding about. Again, if you guys are planning to give an AWS certification, that is the Solution Architect Associate, this is pretty much really important to know, because when you're able to put a use case into an OLTP or an OLAP, you'll be able to get to know which type of storage slash database you need to use. So first, let's go over OLTP. It basically stands for Online Transaction Processing. It says that it processes data from transactions in real time. Now, real time transactions would be, your banking transactions, you're depositing money, you're withdrawing money, or it could be booking systems, wherein you're booking, flight tickets, movie concerts, or anything like that. And it's all about data processing and completing large number of small transactions. So again, large number of small transactions, this could also be related to your banking transactions, wherein a lot of deposits are coming in and a lot of withdrawals are going out. Now you can see the deposit is a small transaction, but multiple deposits, hundreds and thousands and tens of thousands of deposits become a large number of small transactions. Now let's come to OLAP. This stands for Online Analytical Processing. You process complex queries to analyze historical data. So if you have any use case that wants to analyze historical data, this would come under the OLAP category. It basically is used for profit and loss forecasting, sales forecasting, and much, much more. So if you want to forecast something, it could be weather, it could be sales, it could be profit and loss, or anything exact, you would that such use case would fall under OLAP. And finally, it's all about data analysis that is using a large amounts of data. So wherein you want to that's where when you have large amounts of data, that's only when you'll be able to forecast something over there. So hope you guys did get a good understanding related to RDS, what RDS is, what are the different functionalities related to RDS, and why should you deploy your RDS on the AWS cloud. What is OLTP and OLAP, and what are the differences between the two of them? And in today's video, we're going to be taking a demo into RDS. So in the previous video, we had a discussion related to RDS. We had an overview what RDS is, what are the different functionalities, the different engines that are available on AWS. So in this video, let's go ahead and deploy a database on AWS. So as you guys can see, I am on the console right over here. We're going to go to the search and we're just going to type in RDS. And as you can see, the first service that pops up over here is RDS. Let's go ahead and click on that. And you can see it will take you to a page like this. So what we're basically going to do is on the left hand side, we're just going to click on databases. And as you can see, you will have no instances found because I do not have any database created. We're going to go ahead and click on create database. And here you go. This is the create database page. So you got two options that you have. You can go with either a standard create or you can go with an easy create. For this video, I will be going with the standard create so I can show you guys what are all of the options out there. So coming to the first option that you guys have to choose is your engine options. What engine option do you want to choose? Do you want to go with Amazon Aurora, MySQL, MariaDB, Oracle Postgres, SQL Server, or IBM DB2? For this example, I am going to stick to Aurora, and we're gonna go down and you can see your engine version over here. We're going to stick with the default version that is being provided by AWS. Of course, if you go ahead, you can see various different versions available, but for this, I am going to stick to the default version that AWS populates for us. Now, is this going to be a production related database or is this going to be a dev or test related database? I would say go ahead and choose dev and test because when you do deploy this database, you will be charged for it, and productions are again for more high availability and that are pretty fast and consistent. But again, we're just doing this for learning. So I'm just going to change this to dev and test. Now you can provide your cluster identifier, your DB name. Basically, I'm just going to stick it as the default, that is database -1. What is going to be your master username? So this master username is going to be used to log in into your database. Okay. So you can change this to whatever you want. I'm just going to stick to the default because I'm not looking to log into the database. I'm just looking to create a very basic database. Now, you got two options how you can manage the credentials, wherein you can choose managed in AWS Secrets Manager, again, which is the most secure. We have not discussed about Secrets Manager as of now, but yeah, you can say that this is another AWS service out there, or you can do self-managed. Now, if you do self-managed, it will ask you to create your own password and confirm your password. Now remember, you guys will need to make sure that you remember whatever this password is, okay? If you choose RDS Secret Manager, AWS manages everything for you and it's basically highly secure. So I'm just going to go ahead and give a very basic, password. Uh, Maybe we can give something else. Okay, that should be good. And the password should match.
And then we can go down and you can choose your storage configuration. Do you want to have a standard or do you want to have an IO optimized? So if you are having a lot of input output operations, you can go with the optimized. Or if you feel that you have pretty less, transactions or queries that will be made, then you can go with the standard. For this use case, I am going to stick with the standard. And then you can see your instance configuration. You have multiple different types of instances that you configuration you can choose. You can go with serverless. You can go with memory optimized, burstable classes, or optimized classes. I am going to, choose serverless for this option. I would recommend you guys to choose serverless too, as it will be pretty cheap if you are planning to deploy this for a couple of hours. And then you can choose your capacity range, which is the how many Aurora capacity units do you want to have. So you can have a minimum capacity and a maximum capacity. And I'm just going to keep the defaults that are there. And then this is something that is pretty important, that is availability and durability. Now, in a multi-AZ deployment, do you want to create Aurora replicas, or do you want to create an Aurora replica or read a node in a different availability zone? Now, we haven't discussed about replicas as of right now, but this is something that is pretty neat and something that I really like about RDS and especially Aurora. So either you can say that no, I don't want to create any Aurora replica, or you can say that yep, I want to create an what do you say, Aurora replica, or maybe a read replica, but in a different availability zone. So this helps you to have more availability. Now you have connectivity. Do you want to connect it? Do you want your RDS to be connected to an EC2 instance, or you don't want it to be connected to an EC2 instance? And what's the network type? Do you want to go with an IPv4, or do you want to go with a dual stack mode? That means both IPv4 and IPv6. Of course, you can choose if you want to deploy this in a different VPC altogether. What's the VPC subnets and all of those good things? Again, this is pretty important. And the reason why this is very important is because if you're planning to connect to your database through a local, software, if you provide no, you will not be able to connect to your database through the public IP address. You will have to say yes. So RDS will basically assign a public IP address to your database, which will allow you to connect it through applications outside your cloud or through your local computer for development purposes. And then, of course, you can choose your security groups. You want to choose an existing one, or you want to create a new one. If you want to deploy this in a specific availability zone, you can go ahead and choose that. Again, I don't want anything. You also have the functionality to enable RDS proxy. We haven't discussed about RDS proxy yet, but we will be coming to it. And this is pretty good to help you reduce your costs. And of course, your CA, that's your certificate authority, which is again optional. And I'm going to leave all of that as default. And of course, you have your tags and authentication. Monitoring, you can choose your monitoring. Normally, the 7 days is under the free tier. So if you do, what do you say, plan to have monitoring, then choose 7 days for the same. And then we can go ahead and look into our additional configurations. You can choose your initial database name, your parameters and all of those good stuff. What's your backup retention period that you want to back up your database up to 7 days? Do you want to also copy tags to snapshots? Again, we haven't specified any tags for this specified database instance, but if you do, then those tags will also be copied over. And another really important thing is enable encryption. Um, I would always recommend to make sure that encryption is enabled for your database, because if you're planning to create any read replicas or Aurora replicas, then you would need encryption to be turned on. And if you created a database that does not have encryption, then you will not be able to create any replicas. And another pretty neat thing is that if your database is encrypted, any snapshots that are created of your database will also be encrypted. So when you try to, for any XYZ reason, you got to restore back to your database, and if you restore back from an encrypted snapshot, you'll be what do you say, creating a database that is already encrypted. And then you have all of your other basic stuff, and we can just go ahead and click on create database. And as you can see, it says your password is invalid because it should not contain any one of these symbols. So I'm just going to go ahead and change my password, and that should be good. And we can try this again. There we go. Let's scroll all the way back down and let's click on create database. And here you go. I think it is creating our database. Let's give it a couple of seconds. It does take up oh, there we go. It says it is creating our database, and it gives you a pop-up with, suggestions to add on, but we're not going to look into these suggestions for now. And as you can see, your database is being created. Let's quickly go ahead and click on refresh, and we can still see that our database dash one and our database instance one is being created. You can go ahead and you can see when you're going to open up your database, you'll be able to see your various different properties. First coming to be connectivity and security. You can use these to connect to your database. Now, this is your writer endpoint and this is your reader endpoint. So you have two different endpoints for two different purposes, which is pretty neat. Um, as you can see, it defines what's the writer endpoint, what's your reader endpoint. So if you have an application, like for example, let's take a reports application. Now, this reports application generates reports and it does not need to write to the database. So instead of providing the endpoint of the writer, you can just give the reader endpoint and let it read data from your database. And we can quickly go ahead and click refresh again. As you can see, it successfully created database one. And then if you have any IAM roles that were attached, you can do that, or you can also add IAM roles to this. You can share your DB cluster with other AWS accounts across your organization. And if you have connected any EC2 instances, they will be populated right up over here. You can also set up a Lambda connection, which is pretty neat. And this proxy relates to RDS proxies. Again, as mentioned, we haven't discussed about it yet, but we will pretty soon. And we can go to monitoring. You can look, it will show you all of your CloudWatch related. Again, as our database is just deployed, we won't be having anything to see. Any logs and events that took place. You can add auto scaling policies. Um, if X ACUs have been used, then you want to auto scale it, or whatever your criteria is. Any recent events that took place. So we did create our database, hence why we have that. You can go to configurations. You can view all of your configurations right over here. You can do your maintenance and backup related stuff. Your tags, of course, we haven't provided any tags, but if you want to, you can. And any recommendations that AWS does want to provide you will be available right over here. And then we can go ahead to database one, instance one. And again, you can just see your database instance basically. And again, it gives you a pretty good overview over here, saying that what's the role, what's the engine, and which region and availability zone this database is deployed to, and what is the size. So we did choose serverless, hence why you can see serverless over here. So this is pretty much about it related to RDS databases. How can you create a database? What are the different options and features that Amazon provides you with while creating your database? In today's video, we're going to be taking a look into Amazon Aurora. So in the previous videos, we did have a discussion related to Amazon RDS. That's a relational database system, wherein you can create various different relational databases like MySQL, Postgres, MariaDB, and much, much more. And in this video, we're going to talk about Aurora. And as you guys would have seen in my previous videos, Amazon Aurora is AWS's proprietary relational database. It is completely owned and created by AWS. It is not open source. So let's dive right into this video. So first, let's talk about what is Amazon Aurora. It is basically a MySQL and a Postgres SQL compatible database engine. It provides up to 5x performance and it has much lower costs. And additionally, Aurora is owned and managed and developed and maintained by AWS. So let's talk about more about Aurora. You can basically the storage that Aurora has scales in 10 GB increments. So if you guys did watch my previous demo related to RDS and we had to pre-provision our storage wherein we pre-provisioned around 200 GB of storage capacity. So the same applies for Aurora too. You have to pre-provision, but the storage scales in 10 GB increments. Now, what does that mean? For example, if your initial storage capacity is 10 GB, and if you want to increase your storage capacity, you will only be able to increase it to 20 GB. You will not be able to go to 15 GB. And you can each Aurora instance can go up to 128 terabytes. Your compute can scale up to 96 CPUs or vCPUs and 768 GB of memory or RAM. And two copies of the data are contained in each availability zone, with a minimum of three availability zones, which relates to six copies of your data. So, whenever you create an Aurora database, two copies of that database will be present in each availability zone, and there will be a minimum of three availability zones in which your data or your database will be copied to, which relates to you will have six copies of your database, which makes Aurora very highly available. And another sweet feature about Aurora is that it supports cross region replication, which means you can have Aurora databases deployed in multiple AWS regions. That could be US East, US West. You can even deploy it in Europe and much, much more. Moving on, we're going to talk about Aurora replicas. It's pretty much the same that we discussed about related to RDS read replicas. If you want to create an Aurora replica, you can have up to 15 Aurora read replicas. If you are creating a MySQL replica, you can only have up to 5. And if you're doing a Postgres SQL, it can be up to 5 read replicas. Now, the concept of read replicas stays the same no matter you are working with Aurora or RDS. Now we're going to be talking about Aurora Serverless. This is another good feature provided by AWS for the Aurora database. It is really good for unpredictable workloads. So if you have a database wherein you are not quite sure what the workload is going to be, it's very unpredictable. In that scenario, you can go with Aurora Serverless. It has auto scaling capacity capabilities based on usage. Now, what does that mean? Let's take that you have a database that is deployed and you are using 80% capacity of that specified database. Then, if you are using Aurora Serverless, it will automatically scale the compute power and required resources to manage that usage. And a really good thing is that you do not need to have any capacity planning. You can be carefree for capacity planning and you can let AWS take care of that. And you normally pay per second of usage. So each second that you are using your database is where you are going to be charged for. Next, we're going to be talking about Aurora Global Database. Aurora Global Database is, as the name suggests, it's a global database. It's deployed. It'll be globally available. You will be selecting a primary region, and that would be one. For example, if I'm selecting US East as my primary region, our global database will be deployed in US East 1. We can have secondary regions also where we would like our global database to be deployed, and we can select up to 5 secondary regions, which basically means I could possibly deploy my Aurora Global database as a second and uh, up to 5 different secondary regions. One could be Europe, Australia, India, South America, and much more. Again, the secondary regions that will be deployed will only be they will be read only databases. You can also have read replicas, and that is you can have 16 read replicas per secondary region, which basically means if my primary region is US East and I'm looking to deploy this in Europe, my secondary region is Europe, then within the Europe region, I can have 16 read replicas. And another really awesome thing that I like about Aurora Global Database is that cross-region replication takes less than 1 second, which basically means if I am making any update to my primary region global database within 1 second, all of the other databases will be updated, which is really fascinating. And finally, we're going to talk about security related to Aurora databases. It has encryption at rest using the best encryption you have out there. I believe that is AES 256, and it has also supports encryption in flight, that is using TLS SSL. You have IAM authentication. This is basically for connecting to your database. You have security groups. You can consider security groups as firewalls. So what EC2 instances, for example, can connect to your specified, Aurora database, or which IP address could possibly connect to your Aurora database. And finally, it has audit logs, that is everything is logged in CloudWatch. So I hope you guys did get a good basic understanding related to Aurora, what Aurora is, what are the different functionality, features, and security that Aurora provides. In the next video, we will be taking a demo into how can you create an Aurora database and where you can view all of these functionality, features, and much more.
And in today's video, we're going to be taking an overview related to Amazon DocumentDB, followed by a demo related to Amazon DocumentDB. So let's dive right into the video. So firstly, let's discuss about what is Amazon DocumentDB. It is basically a MongoDB compatible database. So if you use MongoDB databases for your workloads and you're looking to move it to the cloud, you can go forward with DocumentDB. It's a fully managed service by AWS. It is highly scalable, so it keeps scaling according to your workload that you have. It does support replication, so data is actually replicated across 3 availability zones, which again provides you high availability. And the document DB storage grows automatically, according to your demand. That's where the scalability comes into play. And the storage, that is where your data is stored, increases in increments of 10 GB. So this was a quick run through related to what DocumentDB is. It's basically a MongoDB database in the AWS cloud. So let's quickly dive into a demo wherein you guys can see how to create a DocumentDB on the AWS console. Okay guys, as you can see, I am on the AWS console, and to be more specific, I am in the database service section of DocumentDB. That's a MongoDB compatible database. You can see it's fast, scalable, and highly available. And of course, you guys can go ahead and also create a DocumentDB database. As you can see, there is a free tier available, 30-day free trial, up to 750 hours on a T3 medium instance, and all of this good stuff. So let's quickly go ahead and click on create a DocumentDB cluster. And you can see we have 2 cluster types. Do you want to go on an instance base or do you want to go on elastic base? So it all depends which use case you have. You can see that both of them are pretty good, but we will just stick with the instance based cluster. we're gonna leave all the things to default. Of course, you can choose an engine version if you have a preference, but I'm just gonna stick to the default version. Now, when you are choosing your instance class, please make sure that you choose the one that is dbt3 medium. It will be mentioned it's the free tier eligible, and the only reason why I'm telling you to choose that one is so that you aren't charged for this DocumentDB. Now, you can of course choose the number of instances that you want to be deployed in your cluster. I'm just going to go ahead and change this to 1. And now you have your storage configuration. Now you have two options. Either you can go with the standard one or you can go with an IO optimized. Again, we aren't going to do much with this database. I'm just going to create this database. So I am sticking with the standard storage configuration. Do you want to set up any connectivity? So are you looking to connect this document DB from an EC2 compute resource? Again, I am not looking to do that, but if you are looking to do that, you can quickly go ahead and set it up right over here. And of course your authentication, how are you looking to authenticate with your what we call it, document DB. You can just quickly go ahead and say anything. I'm going to just say test account. Again, I'm going to go ahead and delete this document DB post creation, so it doesn't matter much. We can just provide in some password. Hope the password matches, and here you go. It shows you your estimated cost. Again, you are eligible for 1 year so you can see it mentioned over here, DB3 medium instances are eligible for a 1-month Amazon DB free trial for new users. Again, do make sure this is only for new users. So if you have created something in the past, please make sure you do not create one, or you're ready to bear the costs. Of course, you have a lot of different advanced settings that you can look into, and we can go ahead and click on create cluster. Okay, I'm pretty sure it's asking port options. I'm just gonna give a random port number over here. I'm just creating it just to show you guys. Yep, there we go. All of the options that we did select were correct, and as you can see, we are creating our document DB cluster. So it does take a couple of minutes, so you can let it run and create, and then of course you can go around, play with it. So I hope you guys did like this video. You got an understanding related to what document DB is, how can you create one on the AWS console, and what are the different options available. So I hope.
And in today's video, we're going to be having a discussion related to Amazon ElastiCache. So let's dive right into today's video. So in today's video, we're going to first dive into the use cases of ElastiCache, and then we're going to go into more details. So ElastiCache is basically used for session management. It's used in search engines, and you can also use it for end of day stock prices. Now, why do we want to use it for session management? Is because session managements are pretty short lived. Their sessions are normally 15-minute sessions or 20-minute sessions. You can relate this to your banking application. Whenever you log into your bank, if you sit idle for about 15 or 20 minutes, it automatically logs you out. The reason why it logs you out is because your session has become idle for 15 minutes and it invalidates your session. So that's where ElastiCache is used if you want to have session management. Now you may ask, what about search engines? The reason why ElastiCache or caches are used for search engines is that it caches the most frequently searched sentences or search stuff on your search engines to provide you faster response. And how can you use it for end of day stock prices? Is that people who would like to view the end of day stock price, once the stock market is closed, the stock price remains the same till the next market open day. So if you have a lot of people who are trying to query the current stock price of a specific stock post market hours, then you can store all of that data in a cache to provide faster response. So let's now talk about what is ElastiCache. It is basically an in-memory database that provides very, very, very high performance with very low latency. It helps to reduce load on your database for common queries. So in the example of the end of day stock market price, now if you have hundreds and thousands of users trying to do a similar query, that is to bring in the stock price of Amazon post market hours, it would be better to store that in a in-memory database, that is ElastiCache. And also, let's take, maybe you are searching some query on Google, how do I create an AWS account for say, and that is something that a lot of people are searching. So Google is like, okay, this may be a common query or a common search pattern that people are doing. So let me store these results in the cache so I can provide faster response. ElastiCache is a fully managed service by AWS. It's completely managed, by AWS. You don't need to care much about the infra and all of those things. It sits between your application and the database. So if this is your application and this is your database, your ElastiCache will be sitting right over here. That is between your application and your database. And you have two types, that is, you can have a Redis type ElastiCache or a memcached one. So let's move forward. So this is basically the architecture diagram that I want to show you guys. This is where your ElastiCache sits. This could be either Redis or memcache. This is your EC2 instance, or you can say your application, and this is your database. Moving forward, let's first talk about the Redis type, ElastiCache. It supports multi-AZ with failover, so it can be deployed in multiple availability zones, and if one availability zone does go down, it can automatically fail over to the other availability zone, which helps to provide high availability. And that's our second point: supports read replicas for high availability. You can also create read replicas for your Redis ElastiCache so you can achieve even higher availability. It supports backup and restore functionalities, so you can create periodic backups of your Redis cache, and also you can restore in any point in time provided that the backup is available. And it also supports sets and sorted sets. Moving on, we're going to talk about Memcache now. Memcache supports sharding. So when you create partitions, multi-node partitions for storing your data. If you guys have know about MongoDB or NoSQL based, over there, sharding takes place. That is partitioning. So that's the same thing that Memcached supports. Another thing to think is that Memcached does not does not have high availability and does not support backup and restore. So it does not have any high availability, and in the scenario that something takes place to your cache, there isn't any backups available, hence why you will not be able to restore. So you can say that all of your data stored in that specified cache is gone. And it has a multi-threaded architecture. And then finally, we're going to talk about patterns for ElastiCache. There are majorly three patterns that we follow when we deploy an ElastiCache service. The first is session. Was one of the use cases that we also discussed about, wherein it stores temporary session data, basically like a token or something which is short lived. So for example, the banking example, um, you know you have a bank, and when you sit idle for 15 minutes, the banking application logs you out. That's where the session comes into play. And then the second we have is lazy loading. And what happens in lazy loading is, the all the data that is present in your database is cached in your ElastiCache and is not frequently updated, which basically means that the data that is stored in the cache becomes stale after one point in time. And then we have the final pattern that we follow is called write through. through, what takes place in write through is that any update that takes place on your database. So if you write anything to your database, you make any updates to your database, those same updates take place in the cache too, which means that your cache will always have updated data and will not be stale. And now finally, I want to talk about how data is retrieved, or how data flows basically. So let's take, you have an application. The application says that I need the current temperature of any place of California, let's take. So your application calls the cache and says that I need the temperature of California. Now, if the cache has that data available with it, it will automatically return the data back to your application. So you can see no call was made to your database. Now let's take, a call was made to your database saying that I need the weather of Texas. And your cache is like, okay, I don't have the weather of Texas. So what the cache does is the cache makes a call to your RDS, to your Amazon RDS, gets the weather of Texas, stores it back into its cache, and now returns it back to the user. So now if another user comes after, maybe sometime, it says that, okay, I want the weather of Texas. So because the weather of Texas is already cached here, it automatically returns back the weather of Texas. So this is basically how ElastiCache works. And again, if you want to implement ElastiCache, it is a lot. It's code hectic. You have to make a lot of application changes, code level changes, so your application can adapt to such ElastiCache.
And in today's video, we're going to be taking a demo into Amazon ElastiCache. So if you guys don't know what Amazon ElastiCache is, you can go ahead and watch my previous video, and then we can dive into today's video. So as you guys can see, I am on the AWS console and we are on the Amazon ElastiCache dashboard. We're quickly gonna go ahead and click on get started, and as you guys know, there are two types of cache that you can create. One is for Redis and one is for memcached. So we're gonna go ahead and create one for Redis. And once we open the configuration page, you can see that we have two options over here. First being serverless, again, which I would recommend is the best option to go forward with. But also if you wish to design your own cache, you can do that too. So let's quickly take a look into the configurations for serverless, and then we'll move on to design our own. Of course, our creation method is going to be create a new one. We're going to give a name. We're going to say my test Redis cache. I'm not gonna go ahead and give any description. Then you can come down and we can look into the default settings. Now of course you can customize these default settings, but again, we are not gonna customize anything. You can see the engine version, your availability zones, encryption in transit is always enabled, encryption at rest is also enabled through KMS. You have security groups, your automatic backups is off, but you can change it after it is created, and you do not have any usage limit set. And of course you can add any tags that you wish to add. So these are the basic configurations for a serverless Redis cache. Now let's look, if we want to design our own cache, what are the different options we can choose from. So you have three creation methods: easy create, cluster, or restore from backup. Let's go ahead with the easy create. You have your configuration, basically which type of for which workload is this Redis cache going to be created. Is it a production workload, a dev or test environment, or are you just demoing? We can quickly go ahead and click on demo. Again, I'm not creating this, I'm just showing you guys the different configurations. Again, you can give any name you wish to provide over here. How would you like to connect? So IPv4 dual stack, that is both IPv4 and IPv6, or just IPv6. And of course you will be creating a new subnet because you do not have a subnet. This is your VPC. These are the selected availability zones that you have. You can also add some tags for the subnet group if you wish to. Again, you can view all of the default settings. It also shows you which are editable after creation. So, the Redis database is deployed on port 6378, and you can view all of these things. And you can see auto failover is by default enabled for you. And again, if you want to add any tags, you can go ahead and add any tags. So that's pretty much about it related to how can you create a Redis cache, and the configurations for memcached are pretty much the same. As you can see, you have two options, serverless or design, and the settings are pretty much the same. So I hope you guys did get a good understanding related to how can you create an ElastiCache on the AWS console, what are the different configurations that you guys can choose. So, and in today's video, we're going to be taking a look into Amazon Keyspaces. So let's dive right into the video. So firstly, we're going to talk about what is Amazon Keyspaces. It's a fully managed Apache Cassandra database in the AWS cloud. So again, if you have any on-prem, or are you working with an Apache Cassandra database that you're looking to move to Amazon Keyspaces is your service that you would be looking to move to. It is highly available. It supports auto scaling. It also supports replication across multiple availability zones. That's where it gets its high availability from. It provides single digit latency, so the latency is very, very, very less. And you have two capacity modes on which you can deploy your Amazon Keyspaces or your Apache Cassandra database in the AWS cloud. First being the provisioned, and second being your on-demand. Of course, if you do choose the provisioned one, you have to pay some X amount of money, but on-demand is pay as you go. So this was a very small overview related to Amazon Keyspaces. The only thing to remember is that it is a managed Apache Cassandra database. So now let's dive into a demo on how can you create an Amazon Keyspaces database on the AWS console. Okay guys, so I am on the AWS console over here. As you can see, I am on the Amazon Keyspaces dashboard. We're quickly gonna go ahead and click on Keyspaces on the left tab, and we are going to click on Create Keyspace. We can give any name that we wish to give, so I'm just going to give the same thing that's provided over there, Keyspace. You can choose your replication strategy. Do you want a multi-region replication or a single region? Of course, if you do choose multi-region, you will have additional costs. So I'm just going to stick with a single region replication. You can see it is replicated across multiple availability zones in the same single region. I'm going to leave the tags as optional, and it is pretty straightforward. It just creates a query for you that is create keyspace with this keyspace name that you have provided with a replication, and you are able to quickly create your keyspace. And there you go, you guys can see that my keyspace has been created. Then of course you can come into Amazon Keyspace and you can start creating your tables. So it's a pretty straightforward process on how can you create a Keyspace database in the cloud. So in today's video, we're going to be taking a look into Amazon Neptune. So let's dive right into today's video. So let's firstly talk about what is Amazon Neptune. It is a fully managed serverless graph database. So if you're looking to deploy a graph database, or you're looking to migrate your graph database to the cloud, then you would go forward with Amazon Neptune. It is highly scalable. It supports read replicas, so up to 15 read replicas is supported by Amazon Neptune. It also supports replication across multiple availability zones, which in return provides you high availability. And some use cases where we normally use graph databases are in social networks. So, you have your social media platforms. That's where you would see graph database being used, or also in fraud detection, wherein you're trying to find different fraud patterns. That's where that's another use case of using a graph database. So this was a very small overview related to what Amazon Neptune is, and let's now quickly dive into a demo related to how can you create a graph database on the AWS console. Okay guys, as you can see, I am here on the AWS console and I'm on the Amazon Neptune dashboard. So this is the dashboard for Amazon Neptune. Um, let's quickly go ahead and create a Neptune database cluster. So we're going to click on launch Amazon Neptune. And again guys, I wouldn't you may be charged for creating this resource, so if you're not willing to pay some amount of money, then please do just watch this video. As you can see, it just gives you a very slight definition that Amazon Neptune is a fast, reliable graph database and all of that. That's pretty good. You have two options. Of course, you can go with the provisioned or the serverless one, whatever you guys like. Again, serverless is something that people are moving to nowadays. Then you also have your engine version. Which engine version would you like to choose? You have your templates. Are you creating a production graph database, or are you looking to create something more for development and testing purposes? I'm going to quickly go ahead and choose development and testing. Again, you can give whatever name and the cluster name that you would like, and any specific instance name that you would like. I again am gonna leave this to the default. Um, just like we had for the DocumentDB, you can also choose your storage configuration. Do you want to go with a standard, or do you want to go with IO optimized? I'm basically going to stick with the standard. We don't need any optimization for our graph database at this point in time. You can choose your capacity selection. So you have your minimum Neptune capacity units, and you can also choose the maximum NC use. Um, Again, I'm going to leave it at the default settings right now, but this setting really comes into play. It all depends how many times are you looking to read and write from your graph database. So that's how these settings would be set. Then you have your availability and durability. Do you want to create read replicas in different availability zones? Again, I do not want to, because of course the more places your database is deployed, the more you are going to be charged for it. And you have your network and security, your VPC, your subnet. You can choose an existing security group, or you can create a new one. Again, I'm just gonna stick with the default security group that we have. You have any tags that you would like. Another good thing about Neptune is that you can also create a Jupyter notebook with your Neptune database. So the reason why you would want to create a Jupyter notebook is so that you can easily query your Neptune database. And again, the Jupyter notebook is hosted in a different service that is called SageMaker. It's an AI/ML service provided by AWS. We have not dived into it yet, but that's where basically this notebook is going to be created. And of course, you can give all the settings. Now, for this use case, we do not want to create a notebook, so I'm going to go ahead and disable that. You do have some additional parameters that you can choose. Do you want to authenticate your DB through IAM or not through IAM? You can choose that. And do you also want to copy your tags when you take a snapshot of your Neptune database? So we can quickly go ahead and click on create, and hopefully if all of the settings are correct, there you go. You can see that our Neptune database is being created, and you can also see we get two endpoints to communicate with our graph database through our applications. And you can also see the type: one is writer and one is reader. And this will take a couple of minutes for it to be created. So that's pretty much it about how you can create a graph database on the AWS cloud. So, and in today's video, we're going to be taking an overview related to Amazon Timestream. So let's dive right into the video. So let's start off with what is Amazon Timestream. It's a fully managed serverless time series database that is normally designed for IoT and operational applications. It is optimized for storing and analyzing time series data. So if you have any time series data that you're looking to store and also maybe analyze, then Timestream is the service for you. It is scalable and a cost-efficient service. And another pretty sweet thing about Amazon Timestream is that it is integrated with SQL to help you query your time series data. And some more things. Now, when it comes to the architecture of a time series database, you have three main things. The first being your data ingestion, wherein it supports high velocity data ingestion from various sources like IoT devices. Now, high velocity is a keyword you should know over here, that IoT devices have a lot of data that they do process or capture. So it does supports high velocity for data ingestion. Then you have data storage. You have two types of data storage. Either it can be a memory store or a magnetic store. Memory store is for the recent data that is pushed into Timestream, that provides you very fast access. And magnetic store is for historical data, maybe data that is 10 days old or 20 days old, can be stored on a magnetic store, historical data with very low storage costs. And then finally, we have the third part of the architecture, that is your query engine. The query engine is actually optimized for complex queries on large data volumes. So in general, time series data is considered to be large volume data, and a lot of complex queries need to be done. So you can write complex SQL queries to query your Amazon Timestream database. So let's quickly head over to the AWS console so I can show you guys a quick overview related to Timestream. Okay guys, so as you can see, I am here on the AWS dashboard. I am on the Amazon Timestream dashboard. So you can basically go ahead and create your Timestream database from here. There is a free tier, but it is only free for live analytics and not for the InfluxDB. So according to your use case, you can choose live analytics or InfluxDB. Most of the people would stick with live analytics. And of course, if you are learning, I would recommend to stick with live analytics, as again, it is also free. So let's quickly go ahead and click on create database. It's gonna be like, do you your database configuration, do you want to go with the standard database or do you want to go with the sample database? So let's quickly take a look into both of these configurations. First, being the sample database, you can provide any name that you wish to, and you can say you want to create tables with sample data. So either you want IoT data, IoT sensor data, or you want some DevOps data. And you can also choose the type of time series records. It could be multi-measure records or single measure records, and you can quickly go ahead and create your database. So as you guys can see, this hardly takes 30 seconds to create a sample database. So you can quickly create a sample database to play around and learn more or test your use cases, or you can create a standard database wherein again you provide your name, you provide your encryption. Do you want it to be managed by AWS? Then it would be AWS Timestream or something else. And then of course you can choose your tags, and you can just quickly go ahead and click on create database. Now you can see in the sample DB it would have ingested data for you, but over here it does not ingest any data for you. You will have to go ahead and create your table and ingest data according to your use case. So that's pretty much it about Amazon Timestream. It's a pretty straightforward process on how you can create a time series database on the AWS console.